as we maybe just kind of go through a couple of these, are there any questions about those first 8 from the first thing? Are there any questions about those first ones? Yeah. Go. Now, one thing I will say is that for 14, you could have 2 different answers. Because you could understand that 2x to be a part of a horizontal transformation that is being stretched, or a vertical transformation if you like did the math. So like there are 2 different answers you could have gotten for 14. Okay. I think it would be just easier to say a vertical stretch of 8, because that's 2 to the 3rd. 15 and 16, I would expect to see maybe some kind of like compression or shrinking language, because there are decimals there. Okay. Then it was 25 through 28. I will say in the past I've given some of those other ones, like 17 through 20, but we never actually transform from we never transform from one transform function to another. It wouldn't be too difficult to figure those out, but we've never really done that. And then we really don't, like for 21 through 24, we really don't graph much more from like the parent function to whatever the transform function is by the end. So you've got 25 through 28. This was like that first example we did yesterday, except you're given the function that you begin with. And somewhere on 28 in your answer, you should have a 2. A 2. Preferably in the front of the expression. Okay. And like counting the little tick marks and all that jazz. So, are there any questions about those 4? Then we flip to the next column, 44 through 50 even. If you took a look at 47, actually the same. And for some of those ones, I don't mind that you're seeing part of the answer. So, yeah. So 44 and 46 are kind of your typical look at the equation, look at the function. It is an equation, but look at the function, identify the transformations. So, are there any questions about those 4? Any questions on the Precalc and multiple choice? When, yeah, that's a great question. When it says to justify your answer, you can either give perhaps a counterexample or just a sentence explaining why it's true or why it's false. So. Okay, well, let's take a look at that question. The function y equals f of x minus 4 represents a translation down 4 units of the graph y equals f of x. Is that true or false? Why is it true then? How do you know that that statement is true? That's all one. Yeah. Yes, and I think what is important is that when we see something like, I'm going to take that number, I think it was number 14, that was this. You could understand this as a horizontal transformation with the two, or I think it's always easier just to talk about transformations in a vertical sense. To say, it's a vertical structure. So because like to say something like this is the same thing as that. I think to describe a transformation with something that looks like this, I think it's just a little bit more complicated. Why don't we try and go as simplest of terms as we can? So. Okay. Make sure your name is on it, and I will. Awesome. So nowhere on. So what's nice about this is nowhere in. So we're not graphing functions yet. It's okay. Oh, it's all right. Sometimes that can be a helpful visual to see what's happening. Put that there. Now we're going to backtrack and finish lesson 3. And I'll, with what we'll finish, I will make sure that we won't be going through a lot of examples, but I will make sure to give you the prompts that you need to do the homework. So this should take maybe 10 minutes. It won't take too terribly long. And I'll even, as we look at the homework, even as you start the homework, we can talk about a few of those problems. So whether you want, this is what I'll say. If you want to continue this in like your 1-6 notes or start a new page, it just so happens that I finished the 1-6 notes at the end of a page, so it's just naturally at the top of the next one. It is totally up to you as to how you want to break that apart. So now we will kind of go back to 1-3. So I'm going to put at the top of this 1-3 continued. Okay. Library of functions. So having that chart out for the homework will be helpful. Okay. Now, this is what I'm going to first do. And I'll explain why. I'll explain some of my reasoning here. I'm first going to give you what the first set of homework problems are from this lesson. 2 through 42 even. You can skip, though, 12, 18, 36, and 40. Okay. Now, these problems, you're going to combine what we talked about in 1-2 with the 6 properties. So like the domain and range, the continuity, the slope, the maximums and minimums, the asymptotes, the end behavior. You're going to use those 6 properties and the 1-6 transformations to solve these problems. Okay. Now that we do this, I'll show it in the book. Prerequisite chapter. Oh, perfect. 1-3. So it's like when you look at this, here's something just worth pointing out. I know that seems like a lot, but these are not asking for a lot of things. It's like problems that are going to take you seconds, ideally seconds to finish. So like, for example, I'm going to, because this one's an odd one, I'm going to cover up these problems. So in exercise 1-12, each graph is a slight variation on the graph of one of the 12 basic functions described in the chart that I gave you. Match the graph to one of the 12 functions A through L, then support your answer by checking the graph and calculating. So this is why you do the transformations first, is because every single one of these functions has some sort of transformation built into it. So that's why we kind of start lesson 3, then we hop to lesson 6 to make lesson 3 homework easier. So it's like when we take a look at this one, well, that looks like a cubic function, and it's moved up 1, so that's why the answer is E. So that's why I feel like doing lesson 6 content first will be easier. Now, in the other ones, so like in 15 through 18, I'll just read this. Identify which of exercises 1 through 12 display functions that fit the given description. So like 13 says the function whose domain excludes 0. And so then what you'll do is you'll look at the graphs from 1 through 12 and say, this exercise models this property. So it's just like looking at the graph and reading it. And then I'll say, once you get kind of over here, you're identifying just the parent functions that describe that property. So like one of them is the 4 functions that are odd. Now that one we aren't doing, but there are 4 functions that have oh shoot, if it's odd, I'm just taking a look at it. Odd functions have origin symmetry, so they reflect over the origin. So like these are just different property things. And then going on through part 2, you're using the graph of the calculator to identify domain and range. So it's just some of those same kinds of questions we're asking in lesson 2, but I think it's a little easier. Okay. The one example then we will do today is we are going to talk about a piecewise function. A piecewise function is a graph that is defined by pieces. We don't see a lot. We really don't see a lot of these in Algebra 2. I think there may be a point where we do some of the graphing. I forget when that happens though. So what we do in this lesson is, in our example, should I say example 1 or example 4? I'm going to say example 1. I'm just going to say example 1. Because it is kind of a new set of notes, and it's got its own like homework assignment. So, all right, determine. So this is the only example that we have for this lesson, because everything else in this lesson we have either seen already in lesson 2 or in lesson 6. Determine if g of x equals, and this is how we write piecewise functions. Determine if g of x equals x cubed minus 3 when x is bigger than 0, and x when x is less than or equal to 0 is continuous. Continuity is something we dive a little bit deeper into when I teach calc. Ironically, I'm starting that today. But even before that, we can figure out if a piecewise function is continuous or not. Now, does anyone recall from lesson 2 how do we describe continuity? And think about the graph. What can we do to the how can we make the graph if the function is continuous? Bingo. So what we need to do is graph this function. Okay. So I'm gonna draw a coordinate plane. I think the easiest is perhaps graphing. You may disagree, but that's okay. There's more than one case. And that's all right. 6. 1, 2. Here. All right. So this is how we graph this. Let's start on the left-hand side. Okay. The reason maybe we start on the left-hand side is because we have a part of the graph where x is less than or equal to 0. What kind of function is this? This part right here. Another kind of function. Like, yep, linear. It's a linear function. It's got a slope of 1, got a y-intercept of 0. Do you think that this symbol, less than or equal to, represents an open circle or a closed circle? Good, because it includes that point. So when I plug in 0 to 0, into x, I get 0. Then I get -1, then I get -2, this is the first piece of our function. Like that. It does not continue past 0. It switches to x cubed minus 3. So if an equal to is a closed circle, what is it when it is not equal to? Open. Now, if it is an open circle, what will that represent on the graph? It will. Because when we plug in 0 here, what do we get here? Yeah, -3. For some reason, I thought I heard -7. Yes, -3. 1, 2, -3. It is an open circle. Now, I know already here, I see that it's not continuous. I'm just going to draw a little bit more of the graph. 1 minus 3 is -2. 2 cubed is 8. 8 minus 3 is 5. 1, 2, 3, 4, 5. So we see that this is not continuous. Okay. There is discontinuity at x equals 0. Okay. Now, here's one thing I will say. One other way you could show this is just by plugging in wherever it splits. It could be 0, it could be 1, it could be -2. You could plug that number in to each part and see if they're equal. If they are equal, it is continuous. If they're not equal, right here, it's discontinuous. So you've got the 2 through 42, you've got the bounds that you're going to skip, and then you have 45 through 46, 50 through 31 on page 103. This is all 103 and 104. Okay. It's 9:39. We have about 11 minutes left. So we will go over this tomorrow. And also, we're finding out after this lesson that we will have our quizzes. Which will probably be back after class, so you can take the part of class to answer questions. So, yeah. And you'll get those, I'll say you'll get those practice problems. I can continue. Because it jumps. There's no way for you, as was said, you cannot practice without picking up your pencil. Yes, it is. It's like these two